This is a picture of a particle of plutonium. I think it's in the lung tissue of some kind of monkey, I think. Anyway, you can see the little lines coming out, the lines coming out of the particle. That's the trajectory of particles as they're emitted from that radioactive particle. And they're causing a lot of damage, and that's those cells right around where the particle is launched. The most susceptible cells are the ones that are reproducing quickly, like blood cells, gonads, especially sperm, embryonic tissue, in other words, a growing fetus or a growing child, and GI tract. And you have to remember that it's continuous and irreversible. Once it starts, you can't stop it. It's the internal emitters, because they're in you, and they have to go down that decay chain until they get down to something stable. Now, people talk about background radiation, and averaged out, it's about 2.4 millisieverts per year. Millisievert is just a measure of radioactivity. Mostly cosmic rays, like from the sun, and then radon. In Canada right now, we are allowed 1.0 millisieverts per year, and that's acceptable extra for the public. And this will be from nuclear, the chronic low-level emission from nuclear reactors, any above-ground weapons testing, and that the old level stopped in the 60s. That is still wreaking havoc now. Nuclear accidents, and then things like medical procedures and air travel will contribute to that. Now, interestingly, nuclear workers in Canada are allowed 100 millisieverts over 5 years, so averaged out 20 millisieverts compared to the public, who are only allowed 1, to a maximum of 50 millisieverts in any 1 year. This translates to about 3 excess cases of cancer, fatal cancer, per 100 workers over a 40-year career. And this is in contrast to any other occupation, which is maybe 1 in 10,000 or 1 in a million. We allow 3 in 100 for nuclear workers. So in terms of safety, worldwide, generally, scientists accept what's called the linear non-threshold model, which means that as your exposure goes up, your risk goes up in a linear fashion. And what that means, too, is there isn't any safe threshold, that any amount of radioactivity is harmful, particularly to children. And also, women are more sensitive than men, and that isn't totally understood from what I've read, why that is. And something you have to remember, too, is when they're estimating these doses, they're assuming that your dose is distributed equally, diffusely over your whole body, which is not the case, because especially the internal emitters, well, with the gamma, too, if it's just one ray, it is localized to whatever tissue it's lodged in. So, and that's an important distinction to make. And another distinction to make is that we don't really know what's safe, and we don't really understand this. We have a very poor understanding of radioactivity in health. The safety standards that we use are based on the LSS, which is a lifespan study of Hiroshima survivors. They looked at 120,000 people who survived Hiroshima, and they tracked their mortality from 1950 to 1997. Now you have to remember, this was a massive blast of mostly gamma radiation, and we're extrapolating that to our exposures, which are generally low-level chronic. They did find cancer, they found all those other illnesses, and interestingly they found the survivors' offspring that were conceived after the blast did not have any increased birth defects in cancer, even though they studied them right up to the late 1990s. However, there were a lot of problems with the methodology of this study, biggest being probably that the control group, which is your comparison group, was people that lived close by. And when your control group is probably also exposed, you're not going to see a whole big difference between your exposed group and your what they consider non-exposed group. They also missed the first 5 years. So all those people that died in the first 5 years are not counted here. And again, it's a one-time blast, which is not really comparable when you're trying to measure chronic low-level emissions. You're also talking about a healthier cohort that survived the first 5 years. And again, today's safe levels are derived from this. So looking at studies that have been done, I'm just going to briefly go over this. Ursula Franklin, who's a professor in Toronto and a very staunch human rights advocate, looked at strontium-90 levels in baby teeth, and this has been used a lot to measure exposures, particularly of the above-ground nuclear testing. And she found the kids that got leukemia had more strontium in their baby teeth. And her work actually contributed to John Kennedy in the U.S. ceasing above-ground weapons testing in the U.S. I think that was 1966. And it's a very good example of how a health professional, through research, can change policy. She also prompted what's called the Tooth Fairy Project, which is still going on out of New Jersey, which is collecting baby teeth from children all over the place, and looking at like children that live near nuclear reactors, downwind from 3 Mile Island, comparing strontium in the teeth of children that get leukemia versus who don't. So it's a very interesting project. In the UK in the 80s, there were some anecdotal concerns about children near facilities, nuclear facilities, getting more leukemia. It prompted the COMARE studies, that's Commission on Medical Aspects of Radiation in the Environment. And then they had some concerning findings that prompted a whole lot of studies in Europe, which I'm not going to get into. But I do want to talk about this one study that came out in 2008 from Germany. It was a case control study, which is a stronger methodology than the studies that have been done before. And they looked at all the kids living around all 16 nuclear reactors and assessed their risk of developing leukemia in radiuses around the reactors. And they found that children under 5 who lived within 5 kilometers of all 16 of their reactors had a higher rate of risk of developing leukemia. This was also done, the same kind of study, and it just came out in January of this year in France. It's called the GeoCap study, the same kind of thing, and they found that children under 15 living within 5 kilometers of all of their 19 reactors had a higher risk of developing leukemia. Double risk, almost a double risk. Canada, we've done almost no studies, very poor methodology, all of them. However, they have indicated some risks of cancer, including leukemia in children with Down syndrome and neural tooth defects, which is a kind of birth defect. But we haven't done any large case control studies and continue to ignore the whole issue. Just a note about weapons proliferation. Plutonium, as I mentioned, is part of the waste, as is tritium. Tritium is radioactive hydrogen, and we produce a lot of it in our CANDU reactors, just because of the way it's designed. But it is also the hydrogen bomb, so it is a target for terrorist acquisition. Also, terrorist attacks. I mean, you just need to drive a plane into Pickering nuclear reactor or any reactor, and you're going to prompt a massive blast and accident. Again, a topic of a whole other conference. There's no meaningful medical response to nuclear war. And I just want to say a word about depleted uranium. This is the waste product after enrichment, and it is very dense and very hard. So they use it. The United States makes bullet casings out of it, and they put it on the outside of tanks. So when these are used in other countries, they've got radioactive bullet casings and radioactive burnt-out tanks all over the place that the civilians are exposed to. Nobody's studied this. Remember, if you want to show that something is perfectly safe and say it with confidence, you just don't study it. So nobody studied Bosnia, Iraq, and Afghanistan, although there are lots of anecdotal evidence that children are being born with gross birth defects, way higher numbers than there were before, and people are getting cancer. As well as the war vets coming back. And again, nobody wants to study it. Although there was one study from Italian NATO war vets from Bosnia that did find higher rates of lymphoma. But that's the story, the unconscionable story of depleted uranium. So I'm briefly just going to go over Fukushima because we've already talked about this a lot. So there was the flood and they lost the coolant. So fires, explosions, meltdowns, contaminated water, air pollution going worldwide, release of all these nuclear fission products, and traces found, of course, all over Japan. Milk, drinking water, and residues on fruits on the west coast, and even over to the east coast of North America, breast milk in Tokyo. Again, a major lack of disclosure of the Japanese, and a lack of monitoring here. Interesting comment from somebody way back in 1972, nuclear power is safe only if no act of God is permitted. Now where does nuclear fallout come from? Well, from the above ground nuclear weapons testing, from nuclear power accidents, and from major nuclear bombs. Inhaled, ingested, and absorbed through the skin. I'm going to talk about these three: iodine, cesium, and strontium. So iodine has a half-life of 8 days, It's a beta emitter, so it's an internal emitter, and it accumulates in the thyroid and causes thyroid cancer, especially in children. It's got a long latency, so we aren't going to see this perhaps for decades in Japanese children or children elsewhere. Cesium-137 is a half-life of 30 years, which means it's around a very long time. It's an internal and gamma emitter. The body mistakes it for potassium, so it tends to pool in soft tissue, so the muscle in the brain, and also in the soft tissue of meat, cows, or any other animal, and then if we eat that, we're eating cesium-137. It causes cancer. And strontium-90, again, a long half-life, and it's an internal emitter. The body mistakes it for calcium, so it deposits in the bones and the teeth, which is why you can measure it in baby teeth. And it causes bone cancer and bone marrow cancers like leukemia. And again, interesting, you should look up the Tooth Fairy project. It's very interesting work being done. So what studies have been done in terms of the above ground testing? Well, the National Cancer Institute of the US did a study looking at iodine-131. Again, there are many, many, many toxic products. They're just picking one. This is a map that they they made of the exposure. So the lowest exposure is the lightest red. It goes up, and then it increased exposure through into dark red, light blue, into dark blue. So the most exposure is over on the west coast, which makes sense because it was Nevada. And just because of the prevailing winds and rains, a lot of it ended up on the east coast. And again, a lot of it got into the cow's milk, and then of course children drink more milk. So, but when you actually look at the study, there are remarkably few actual measurements done, and a lot of it's based on estimates and assumptions, and they could be way out with these measurements. But they estimated that about 55 million people who were exposed under the age of 20, well, that they were 55 million people exposed under the age of 20 starting in 1952, and they estimated over 200,000 excess thyroid cancers to be expected over a lifetime. And again, the latency can be decades with this cancer. And this is interesting. They figured the average exposure was 2 rads with a big range from 0.1 up to 16. Now, just to give you some perspective, our 1.0 millisievert is 0.1 rad, and that's what we're allowed in a year. So their average was 2.0 rads, going up to 16 rads. So there was significant exposure to iodine-131. Again, children are more vulnerable than adults. And just last comment about Chernobyl. This happened in 1986, level 7 accident, which Fukushima actually eventually did attain. Massive explosions, big plume going up 9 kilometers and going worldwide. About 200,000 times the strength of the Hiroshima and Nagasaki bombs. And massive evacuation. Now, how many people died? Well, initially, and there's still people that believe that it was about 31, and these were the workers. And then United Nations Scientific Committee on the Effects of Atomic Radiation said, well, maybe were as many as 64. And then the IAEA, a very pro-nuclear organization, along with the World Health Organization, did another estimate and figured it might be 4,000. And then Greenpeace looked at all the studies and estimated up to 200,000 excess cancer, and that's just cancer deaths. They found increases in all sorts of illnesses, cardiovascular, chromosomal aberrations, etc. But they did find a lot of poor research methodology. And then this book came out, I think it was last year, 2010 maybe, and it's a collection of it's looking at and analyzing all of the studies that were done, including the Eastern European studies, which everybody else had dissed. And this fellow, I think it was Yablokov, was the co-founder of Greenpeace in Russia. So they estimated almost 1 million premature deaths, which in fact intuitively makes a lot more sense when you look at what really happened. But again, this is very controversial, and you can look at it online, but again, you're not looking at every single study. He's looked at thousands of studies and made a comment at the end, estimating 985,000 premature deaths. But so my feeling is there are a number of very intelligent, well-informed, level-headed scientists who say that overall this is to be relied on. So in summary, radiation is harmful in any dose, particularly to children and growing fetuses and women. And a nuclear accident can happen anywhere, anytime, and it's catastrophic. So I think I have 5 minutes or so. Do you have 5 minutes?
10 minutes for questions.
Oh, okay. 10 minutes for questions. Anybody have a question? Yes.
So, there's a lot of things which you said which is inaccurate. But I think that if you go back to conclusions, I would like to make one single point. All right? And my point is that
Can't hear you.
can you hear me? My point is, if it's true, if it's
Turn the mic
oh, okay.
on.
I don't know how to turn it on. So if
There's
it's
another
if,
one.
all right, I'll just speak louder. Okay. So, can you show the conclusion slide? All right. If it's true that IR is harmful in any dose, and that there is a background dose, if this statement is true, the human race would have been extinct a long time ago.
Well, you have to look at the numbers.
No, yes, so you can measure the dose, the background dose of radiation, and we are exposed to any dose, to the background dose of radiation. So if your statement that IR is harmful in any dose, right, and we have the dose of radiation, it implies that this is a harmful dose, and we are exposed to it for millions of years.
But that's why we have more than, we're trying to get at least replacement in our population. Because we will die prematurely. So you need to have, what is it, 2.2 children to just replace yourself. Because it's natural that that background radiation is going to cause illness, that's going to kill people prematurely. And also, this is accepted worldwide and generally in the scientific community that it's a linear non-threshold model. So any small amount is harmful, and it's cumulative. It doesn't mean you get 1.0001 millisievert and you're going to die. It's cumulative. And you may be lucky and it won't get you, but you may be unlucky and you'll die. Yeah.
Why is there less strontium out of the Fukushima disaster than, for example, cesium? I thought there would be equal amounts. Is there some reason for that?
You know what? People after me are going to be talking about what's actually coming out of nuclear reactors and why. Anybody know? I don't know.
Well, when the strontium that we mostly see are from bomb fallout, so the reactor actually is quite a bit different in what it released than when it's released from a nuclear weapon. Most of the strontium is from fallout.
Just quickly, it's because of the difference in the burn-up rate. An atomic bomb, the burn-up rate is instantaneously, so there's more strontium produced, whereas a reactor operates basically on a more moderated burn-up rate. So that's why.
And so less is produced.
That's right.
Okay. Thank you.
Yeah, one of the slides I thought said that there was no monitoring in Canada and the U.S. following Fukushima. I looked at the Health Canada website this morning. They mentioned that there are some stations.
Yeah, I looked at those too. I think there are, and as I remember, it got less. There are only a handful of them. Most of them are in Western Canada, I believe, and people probably know more about the monitoring than I do, but it's sporadic and certainly not as much as it should be, put it that way, especially on the West Coast. Yes?
No, yeah, sorry.
Yeah, to clarify that a little bit is
what they did is they moved our monitoring stations from Vancouver Island, where they could catch in any rainfall and that, where they were doing an excellent job of monitoring, and they moved them up to the Kamloops area where it's very, very dry and it doesn't much rain. So as you know, that when it rains, we're getting about 1.66 megaservices an hour in radiation exposure here. And of course, it was to their best interest. And it took them 4 months after Fukushima they immediately ceased checking milk for radiation levels. And then it took us 4 months to try and get them to at least check 3 times a year for radiation levels in the milk.
And just to mention, there are now in Japan, I believe, 20 millisieverts a year. That's the allowable level, and anything under that is considered safe. Here is 1.
I think it might be helpful for people, if you would please identify yourself and where you're from when you do your question.
Hi, my name is Dennis, and I'm from Victoria. I'm a chemical engineer. I'm from Europe origin. Lived through the Chernobyl accident there. I just had a comment regarding the impression that was posed to you at the beginning regarding that the first statement up on here in the summary are as harmful as any dose. Apparently it's not, according to the doctor over here. If that's the case, that nobody would ever get cancer if you were in an environment that wouldn't be any infrared radiation or infrared radiation. I think we all know that fish develop lungs over millions of years, and eventually they came out of the water onto land. And that was probably due to genetic mutations. That took a long time. Some mutations were beneficial, other mutations were not beneficial. Would you not agree to that? You agree to that. That's great. So if the background radiation is at a certain level that allows for natural systems to, over a long period of time, to have genetic mutations that are beneficial, in some instances allows various species to be created over a long period of time. If you now change the background radiation to a higher level, where suddenly various life forms will not be able to live a useful life, actually die before they're able to pass on their genetic information to the next generation, that will hamper and change the ability for life to multiply and to evolve. Would you not agree to that as well? If the radiation level is too high, that you would die?
I question any dose, and what you're saying is just...
So the point is, so fair enough. So I think the point is that it's, if you have a certain amount of background radiation, there could be a level where it's not negative, it actually is beneficial for species to evolve over a long period of time, but if the radiation level actually increases to a certain point, that could actually become negative, and in fact it could actually extinguish life, just as what you said.
So, based on your statement, can you agree with the first statement?
Yes, absolutely.
That it's harmful
Maybe
in
we
that
take
Yes.
this discussion elsewhere.
No, it is harmful, but the problem is that the body has the ability to repair various damage that's caused by it. But there comes a
We
threshold.
don't have time for genetic mutations, sir. Can we stop?
Okay.
Does anybody else have any questions?
I'm glad we got this out there right off the bat, because there is obviously a lot of disagreement in the scientific community even about whether the non-threshold theory is correct or not. And it's
Actually, I don't think
extremely
that's true. I think it's generally accepted now.
okay, but it's not completely accepted, as we heard from our audience. My point is only that we are, in terms of our epidemiology, unable to determine at the low end of the linear non-threshold line, we're unable to determine exactly when and how the line hits zero. There are many experiments that have been done to suggest that indeed there is no threshold. There are other experiments that suggest maybe there is, and there are even experiments to suggest that hormesis, the theory that a small amount of radiation is good for you, all of this evidence is out there, and we're still 60 years on trying to figure out exactly how all of this evidence is relevant to humans, and I appreciate that there is confusion in the public about this. We're going to continue to go forward and hopefully learn a lot today about what we should do as a public with the level of information that we have today. So thank you very much for all your questions. Is there another? We do have a couple of minutes.
My name is Rudolph. I'm just a local resident here, and I was always wondering whether there's any bomb testing, and maybe including nuclear testing going on in interior or northern DC.
No, fortunately, there's no testing going on at the present time. The United States has a temporary ban on testing. The Congress has yet to pass a comprehensive test ban. We have multiple stations around the globe that are poised to detect nuclear tests. And as far as we know, there has not been nuclear testing since the North Korean test. Just prior to that was Pakistani and Indian tests. It's been, fortunately, many years since the last test.
Sorry to miss your presentation earlier. I cannot believe your person from having been exposed to some 40,000 chemicals in the fish in the Gulf of St. Lawrence and including radiation. But what I would just like to encourage people to do is, for their homework, to go home and Google up the children beyond Chernobyl, and please accompany yourself with a large quantity of toweling, paper toweling, because it's very heartbreaking to watch, but it's very dramatic, the effects on children's health because of the formation of their bones, and they're close to the ground, and they're always putting their hands in the mouth and whatnot, and eating local berries and whatnot. So the effects are very dramatic, but it's the same in adults as well. They will be, if they're exposed to large amounts of radioactive toxins.
Do you have a question?
No, I'm just saying this, I'm just giving people some homework to do because it saves a bit of time. People do that on their own. And they say, my condolences.
Thank you. Any other questions? Yes.
Yeah, my question is Chernobyl was my understanding that it was 3 months worth of active fuel rods, radioactive fuel rods that blew in Chernobyl. And in Fukushima, we had over 40 years worth times 3, plus there had been active fuel rods brought from other plants for storage in Fukushima prior to the blow up. March 11th, and they also there were 40 years worth of active fuel rods from 3 other plants in there. I was wondering, have you ever done any calculation as to see how many more spent fuel rods and how much more powerful they were than actual Chernobyl that killed 1 million people?
No, I have no idea.
Has anyone done that math yet?
I believe we will hear more about the comparison from Duncan next. So
Okay,
I
thanks.
think we're going to need to move on, and we'll have next.
Thank you very much, Kathy. Our next speaker has been waiting patiently, I think in his living room or his office. Mr. Arne Anderson is the co-author of the first edition of the United States Department of Energy's decommissioning handbook. He has had over 40 years of nuclear power engineering experience, and at one point he was coordinator for projects in more than 70 nuclear power plants in the United States. He's come from the dark side. His colleague, friend and wife, Maggie Gunderson, is also with him part of the Fairwinds Associates, which provides information and consultation on nuclear power and nuclear radiation in the United States and, as of today, Canada. Please welcome Arne Gunderson.